10.3, plots matching measures. Create a possible dot plot with at least 10 values for each of the conditions listed. Each dot plot must have at least 3 values that are different. So number 1, a distribution that has both a mean and median of 10. So the reason they're saying you need at least 3 different values here is because this would be super easy, right? I could make my number line and then just put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 dots right there at 10, and that would have a mean and median of 10. Since every value is 10, there's no other possible value I could have. So that would be cheating, right? So they want you to be a little more creative and do 3 values. So when I think about something being having the mean and median being the same, that means that it's going to be symmetric. Perfectly symmetric, not vaguely symmetric. It's got to be perfectly symmetric for that to be true. So there's quite a few different types of graphs I could do for that. I know that my median is going to be 10, so I'm always going to put 10 right here in the middle. Then on either side, I'm going to balance it out with an even distribution on both sides. So I put 3 for 9 and 11. Then when I do 8 and 12, maybe I'll put 2 also. All right, so that'll give me 11 dots. That is a distribution that, because it's symmetric, mean is going to equal the median when symmetric. Okay. Another example you could do, you would just always have to really have 10 in the middle here. So let's say I want to do a uniform now. Let's give 10 3 dots. Let's give 9 3 dots. 11 3 dots. 8 3 dots, and 12. As long as I have the same frequency on both sides of 10 in the same interval apart, I know it's going to be a symmetrical distribution, and 10's right in the middle, so that means we're going to get a mean and median of 10. So what I'd like you now to try for number 2 is to list a set of numbers that would have both a mean and median of negative 15. So for example, if I was doing this one right here, I would write 8, 8, 9, 9, 9, 10, 11, 11, 11, 12, 12. All right, please write them in ascending order. It'll make it much easier for me to understand exactly why you picked that. If you just write them randomly, I'm just going to say, well, first, no one really thinks like that, randomly. Unless you have a method to how you pick the numbers you can explain, but please write them in ascending order. So try that for negative 15. All right, so for negative 15, you could have done an example where it's bimodal or uniform. I'll show one where it's like a normal distribution. So again, if it's normal, that means my median is going to be right at the highest point. I'm sorry, did I say normal? I meant bell shape, sorry. You don't know what that is yet. If you take stats later on, you'll know what a normal distribution, although in Algebra 2, I think everyone does. So it just means bell-shaped. So I'm going to put negative 14 on this side, negative 16 on that side, and just slowly start to lower it down. All right, so I've got a symmetric distribution. My middle is at negative 15, so I know that my mean and median are both going to be negative 15. All right, number 3, we've got a distribution that has a mean of 2.5 and a mean greater than the median. So the first thing I'm going to do is I'm just going to make my number line and make sure that 2.5 is right in the middle. All right, so now I want to figure out, well, if my mean is greater than my median, let me think. Well, we see that when the mean is greater than the median, we have something that's skewed to the right, meaning that I've got way more single dots trailing off to that right side. So I'm going to do the same thing here. I may have, 3 dots at 2.5. Now let's say I want to add 5 dots. Let's add 3.5, 4.5, 5.5. Let me extend this. Let me keep this going to really show that we've got a skew here. 6.5. Let's go all the way to 7.5. Really exaggerate it. So I'm going to add 1, 2, 3, 4, 5. Now I want 2.5 to stay in the middle, so I'm also gonna add 5 dots on the other side now. So let's even make it very dramatic. Let's just add 5 to 1.5. Right, you can clearly see this is like sloping down. I know I said don't use the word slope, but you know, it's sort of like sloping down, going towards the right. That means that my mean is going to be pulled away from the middle. So the mean will be greater than the median. All right, and my middle is definitely 2.5 based on the number of dots I put. All right, a distribution that has a mean of 5 and a median greater than the mean. So now we're reversing it. We want mean to be less than median. So that's going to refer to, again, our skew, and this will be a negative skew, where the mean has to be less than the median, meaning it's got values over to the left pulling the mean away. So try and come up with a data set that represents that. All right, so hopefully the first thing you thought about doing was putting 5 right in the middle. And then let's put 3 dots at 5. And now we want it to be pulled away, so I'm going to really stretch it in this direction. Let's go to -1. Let's really make it dramatic. All the way over here. And I can even, I can do, that's how I want to do it. Good. So 1, 2, 3, 4, 5, 6, 7. So now on this side, I'm going to put 7 dots also. All right, we can see that, again, it's sloping downwards, like you're going downhill. Well, that's sort of hard to, I wouldn't think about it that way, sorry, because you could say you're going downhill there too. As you follow towards the tail, you're going towards the left, going negative, going down. So that's bringing the mean down with it. So that would be an example of something like that. All right, that is all for 10.3. Have a great day.